Hello all. In this video, we are gonna discuss about Group 1 elements alkali metals, chapter DS block elements, subject chemistry, class 11. Elements of Group 1 are lithium, sodium, potassium, rubidium, cesium. These are known as alkali metals because they form hydroxides on reaction with water which are strongly alkaline in nature. Lithium shows similarities to magnesium in many of its properties. This type of relationship is categorized as diagonal relationship in the periodic table. The diagonal relationship is due to the similarity in ionic sizes or charge by radius ratio of the elements. All the alkali metals have one electron in their valence shell, hence their general electronic configuration is noble gas plus ns1. N represents the principal quantum number. Alkali metals are the most electropositive elements due to the loosely bound electron in their outermost shell. Hence, they readily become monovalent M+ ions by donating the valence electron. Here, in this table, we can see the complete electronic configuration and valence shell electronic configuration of alkali metals. With increase in atomic number, the atom becomes large due to the addition of new shell. The monovalent ions are smaller than the parent atom due to increase in nuclear charge. The atomic and ionic radii of alkali metals increase on moving down the group. Here we see the sizes of alkali metals being increased as we go down the group. The hydration enthalpies of alkali metal ions decrease with increase in ionic sizes. Lithium ion having the highest hydration enthalpy while cesium ion has the lowest in the group. Lithium ion has maximum degree of hydration and hence lithium salts are mostly hydrated. Example, LiCl.2H2O. The ionization enthalpies of alkali metals decrease down the group from lithium to cesium. This is due to the effect of increasing size which outweighs the increasing nuclear charge. This also explains the adequate screening of outermost electron by the inner shells. Coming to the physical properties of alkali metals are silvery white and soft. These elements show low density which increases down the group from lithium to cesium because of large size. Alkali metals and their salts impart characteristic color to an oxidizing flame. This is because the heat from the flame excites the outermost orbital electron to a higher energy level, and when the excited electron comes back to the ground state, there is emission of radiation in the visible region of spectrum. In this table, we can see the characteristic colors being shown by the group 1 element's flame. Lithium shows crimson red, sodium shows yellow, and potassium shows violet. Similarly, the rest. The melting and boiling point of alkali metals are low, indicating weak metallic bonding in them. Alkali metals can therefore be detected by this flame test, and this flame test is used in flame photometry and atomic absorption spectroscopy. Alkali metals, when irradiated with light, the light energy absorbed may be sufficient to make an atom use electron. This property makes cesium and potassium useful as electrodes in photoelectric cells. In this table, we see different physical properties of group 1 elements. Observe the trend of standard potentials for group 1 elements and see the melting and boiling points of group 1 elements also. Next, we discuss about chemical properties of alkali metals. Alkali metals are highly reactive due to their large size and low ionization enthalpies. Reactivity of alkali metals decreases down the group. Alkali metals tarnish in dry air. Ever wonder why? Because they form oxides which in turn become hydroxides in presence of moisture. Lithium forms monooxide, sodium forms peroxide, while other elements of group 1 form superoxides. Note that the oxidation state of group 1 elements is always +1. Here is one problem for you. What is the oxidation state of potassium in KO2? Answer: oxidation state of potassium is always +1. Reason: KO2 is a superoxide and oxygen exists as O2-. Alkali metals react with water to form hydroxide and dihydrogen. Metal plus water gives metal ion plus hydroxide ion plus hydrogen gas. Lithium reaction with water is less rigorous than that of sodium, though lithium has the most negative enthalpy, as we have seen in the table earlier. The reason behind this is lithium's small size and high hydration enthalpy. Other metals of group react explosively with water, and they also react with proton pores such as alcohol, gaseous ammonia, and alkynes. Reactivity towards dihydrogen. Alkali metals react with dihydrogen at about 673 Kelvin to form hydrides. The general formula for alkali metal hydrides is MH. M represents alkali metals. All the alkali metal hydrides are ionic solids with high melting points. Reactivity towards halogens. Alkali metals react vigorously with halogens to form ionic halides. Lithium halides are covalent in nature. This is because of high polarization capability of lithium ion. Lithium ion is very small in size and has high tendency to distort electron cloud around a negative halide ion. Hence, The anion with large size can easily be distorted among halides, and lithium ion iodide is the most covalent in nature. Reducing nature of alkali metals. Alkali metals are strong reducing agent, lithium being the most and sodium being the least powerful reducing agent among the group. With the small size of its ion, lithium has the highest hydration enthalpy, which accounts for its high negative enthalpy value and high reducing power. Here we go through another problem. The enthalpies of various reducing agents have been displayed. Arrange them in decreasing order of reducing strength. Answer is lithium greater than sodium greater than iodide ion greater than silver greater than chloride ion. The reason behind this is the enthalpy values as given in the data. Electron affinity less means reducing agents, better reducing agents. Solutions in liquid ammonia. Alkali metals dissolve in liquid ammonia, giving rise to deep blue solutions that are conducting in nature. Here in the reaction, we see a metal complex being formed with ammonia as acting as a ligand to the metal. The solution is blue in color due to the ammoniated electron which absorbs energy in visible region of light. Also note the solution is paramagnetic in nature, but in concentrated solution the blue color changes to bronze and the solution becomes diamagnetic. Uses of alkali metals. Lithium with lead gives white metal used as bearings for motor engines. Lithium with aluminium is used to make aircraft parts. Lithium with magnesium is used to make armor plates. Lithium is also used in thermonuclear reaction. Lithium is also used to make electrochemical cells. Sodium is used to make a sodium lead alloy, which is needed in making organolead compounds used as anti-knock additives in petrol. Lithium sodium metal, liquid sodium metal is used as a coolant in fast breeder nuclear reactors. Potassium chloride is used as a fertilizer. Potassium hydroxide is used in manufacture of soft soap. It is also used as an excellent absorbent of carbon dioxide. Cesium is used in devising photoelectric cells. Facts. Francium is highly radioactive and its isotope is longest lived. Alkali metals have largest sizes in the particular period of periodic table. Here we come to the end of this video. Thank you.